This is a lesson for 5.2 polynomial functions. We first of all want to review what a function is. And a function is when we have a relationship between two variables. And in that function there are various things. We have the domain and we have the range, the set of x values and the set of y values. And in that relationship, each x value has exactly one element in the y value set. Notation for functions, we use the f of x for our function notation. We can also just use y, but either way we're talking about polynomials that are functions. There's an output, which is that y, or the f of x, and the input is the x that you put into this function. Now, there's names of functions, things like there's the constant function and the linear function and the quadratic and the cubic and the quartic and the quintic, and they have all these different names. The main thing is they're in the lesson that's in Apex, and I want to make sure that you are reading through the entire lesson. It's on page 3, so you should look at the chart in Apex on page 3, their lesson, and get to know those functions, the names of them. Evaluating a function, a polynomial function. Please do not say solve. It is not solving. We're talking about evaluating. Evaluating is when you substitute a value in for x and you simplify. You're going to find the value of the function. That's why the word is evaluate, to find the value of. Solving is saying, I'm going to solve for a variable that I don't know the value of, and that is different than finding the value of the function. Graphing. There's a lot about polynomial functions we're going to do with graphing. And the first thing you can think of is what you learned back in Algebra 1 days, which was make a t-table. And you can make that t-table and plot in a lot of points. When you did lines, you only needed 2 points in a t-table to graph a line. But with polynomials, you need a lot of points. You've got to have at least 5, 6, 7, and better. The more points you have, the better it is, because you're going to find that there's a lot of aspects about polynomial functions that are change directions and such. So you need lots of points to see that. Because polynomials are what we say is smooth and curvy. They're continuous functions. They have patterns in those graphs and that smooth and curviness. So here's a polynomial that we've looked at before. This is a parabola. And this one it's smooth and curvy. This one here, this is a cubic function. Again, it's smooth and curvy. This is a quartic, a quintic, and then we stop saying the funny names and we just say certain things about them. And the things we know, when I was saying that we had this one is a quadratic and this one's a cubic and a quartic and a quintic, there's another thing we're saying about that, and that has to do with its degree. So this is a second degree, the polynomial of second degree gives you a quadratic, which graphs a parabola. We have a polynomial of third degree, which is the cubic. We have a polynomial of fourth degree, fifth degree, sixth degree. So there's a pattern here, and look at the pattern. When the degree is 2, it has one valley or hill. Depends on which way you think of it. This one turning place, we're going to talk about that in a minute. A third degree has 2 turning places. A fourth degree has 3 turning places. A fifth degree, well, there's 1, 2, 3, 4 turning places. There seems to be always one less than the degree. Let's come up to the sixth. 1, 2, 3, 4, 5. It is one less than the degree. So the amount of turns that this takes to make the curviness is always one less than the degree. Also notice that with the second degree, the end behaviors, here we're going to talk about that in a moment again, but the end behaviors both point up. Here the end behaviors both point up, and here the end behaviors both point up. And it's 2, 4, 6. Even numbers, even end behaviors. Odd degree, and we have odd end behaviors. One's pointing down and one's pointing up. In the third degree, they're odd, they're off. So there's one is down and one is up. The leading coefficient in the equation, we're talking about the very first term of the highest degree. So we call that a sub n, and it's x to the n. And this is one of those notations we have for polynomials that we would have all the other letters. But I'm just saying the very first one is what we're going to look at, the leading coefficient in regards to our graphs. When our leading coefficient, this a sub n, is negative, it's going to flip the graph. The way to really think of it is this, is the end behavior, the right end behavior though, not both end behaviors, just the one on the right. When my leading coefficient is positive, that's what I say here, I don't say greater than, I just say when the leading coefficient is positive, the right end behavior is going up. So I'm looking at the right side of the graph is going up. When the leading coefficient is negative, the right end behavior is going down. It's a decreasing function on the far, far right. So I'm looking at this polynomial, this graph is smooth and curvy, and this is a polynomial, and all I'm looking at is this end behavior. I'm not going to talk about the degree or anything. I'm just saying, end behavior here, that means my leading coefficient is positive since it's pointing up. We could look at this and say it's also going to be an odd degree, and we can count 1, 2, 3, 4. Oh, this is a 5th degree, and it's a positive leading coefficient. Here we're looking at our right end behaviors going down, so our leading coefficient is negative. Our leading coefficient is down, so once again, and I shouldn't say our right end behavior is down, so our leading coefficient is negative. And this one here, our right end behavior is up, and so our leading coefficient is positive. So this is about leading coefficient and how the behavior is on the right side of the graph. Maximums and minimums. They're also known as the extreme values. That word in this terminology is used a lot now in higher math, that we're going to talk about the extremes. And it's about what's around it, not necessarily the whole thing. Sometimes we have thought of maximums and minimums as vertices, but only in particular types of polynomials. Absolute means nothing will be higher if it's a maximum, or nothing will be lower if it's a minimum. So everything else is going to be below if it's a maximum, and everything else on the graph is going to be above if it's a minimum, and that's when it's absolute. The other type of maximum and minimums are relative maximum and minimums, and what this is saying, those hills and valleys that we see in the curviness, anything that is atop of the hill, it's going to be a relative maximum, and anything that is the bottom of a valley is going to be a relative minimum. So let's look at a couple of these graphs. I've got this one here, and I'm going to say, all right, I'm going to look at the relative maximums, and I have these 2 points here are relative maximums because they are higher, they're the top of a hill, but I didn't say, this one is, you could say it's a relative, but more importantly, it's the absolute max because everything else is below that. These are all maximums, and this one's the absolute, and these are the relative. We have relative minimums, which would be those valleys, which would be these two lower spots right here. Whoops, here and here. But what about absolute minimum? Well, in this problem, because it goes on forever and ever down, there is no absolute minimum. Now, note these maximums and minimums. We're going to talk about the coordinate points for these, and you're going to look at graphs to figure them out. But the only ones that we can find truly on the absolute maximum mims are for quadratics. And we have done that because we have found the vertex, HK. And that was in a previous lesson. And so go back if you say, oh, I don't remember how to find my vertex, my HK for a quadratic. This is something we're supposed to have memorized, that H is negative b over 2a, and K is when you plug that into the function. So this is the only one that we're going to be able to find in this class, in Algebra 2, at these values for either absolute or relative. We can't do that in Algebra 2 easily. We can do that that's one of the things you learn about in calculus. Next topic are roots. Roots of these graphs. They're also called the zeros and also called x-intercepts. This is what we see graphically, x-intercepts. Roots is a generic term for it. It's got a lot of meanings for why that is, the roots. But this idea calling the zeros makes a lot of sense, because it's when the function is equal to 0. And we can either say f of x equals 0 or y equals 0, but that's why they're given the name of zeros. So we're saying when the function is equal to 0. The method to find the roots is to set the function equal to 0 and solve for x. Well, that's easier said right here than done. Sometimes we have to learn methods, and the main method is to factor. Well, we've been factoring lots of quadratics, so we've got many different skills and techniques to do that. And what we're going to be doing in tomorrow's lesson and future lessons is finding new strategies of factoring higher degree polynomials, the cubic and the quartic and the quintic. How do we factor those kinds of polynomials? And that's what we're going to learn.